This is Professor Pelton. This is Algebra 2, Chapter 7, Section 3. We're still multiplying and dividing rational expressions. So we're going to start with multiplying in this section. So simplifying and multiplying are very similar because multiplying is just a process of multiplying straight across. So all of these simplification techniques still apply. So if you multiply straight across and just combine things, you end up having 5 times 2 times 3, because 6 is 2 times 3, obviously. Then you have x to the third and y to the third, because the product rule of exponents says add. And then on the bottom, we have 2 times 2 times 5, because 2 times 5 is 10, x to the 1, y to the second, since we have a 1 there and a 1 there and a 1 there. Okay, now we can cancel. Cancel, 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 cancel. So we have 3 over 2 numerically left. x3 over x1 is x2, and y3 over y2 is y1. Make sure those are in the numerator because it's quotient rule for subtraction. Okay, so that's what we did in monomials in Algebra 1 as a review. Please try the Algebra 1 review problems below. Pause the video. Okay, so here we're going to multiply across. So the 8 is 2, 2, 2, and a 7. And we have 7 x's and 4 y's. And on the bottom we have 2, 2, and 2, because 4 is 2 times 2, x1 and y3. So cancel numerically. So we're left with 7 over 1 numerically, or you can just put 7. x6 because it's x7 minus x1, and y4 minus y3 is y1. So you can simply write x6 y1. And we're not going to specify domains here because it's just x and y can't be zeros because they're singular monomial terms, meaning 1, right? Okay, next one, 3 times 2 times 3, x to the 6th, y to the 4th. And on the bottom, 2, 2, 2 for the 8, and 3, 3 for the 9, x4, and y2. Okay, so 2 of the 3's cancel, and 1 of the 2's cancel. So you're left with 1/4 numerically, and x2 and y2 algebraically. Okay, so the 4 is on the bottom, and you don't necessarily need the 1 on top. It's just the common factor that's left after all the numbers cancel. All right, so now we're going on to what we want to do in Algebra 2, which is polynomials, not monomials. So the same rules apply, except we have to, in the case of polynomials, use factoring techniques, whether that's quad form factoring or factoring out or something of the case. So again, you can just make them one singular term because it's multiplying and multiply straight across. So we have x minus 7, and then x squared plus 0, x minus 1 is the other term. On the bottom, we have x minus 1. The 3x and 21 have a common factor of 3, so I can factor out there. Okay, so on the top now I can do quad form factoring, so I get x minus 7. Okay, and then that's going to be 1x, 1x, and then that's 1 times negative 1 is negative 1. The only factors are 1 and negative 1 because I need to get 0 as the middle term. So now I have on bottom x minus 1 times 3 and x minus 7. So the x minus 7's cancel and the x minus 1's cancel. So I'm left with a final term of x plus, my pen messed up there. Let me erase that real quick. For some reason the x jumped to the second line. X plus 1 over 3 is what's left. But again, we have domain restrictions because you cannot divide by 0. And that is true where x cannot equal 1 or 7, because if you look at the original problem, if you plug in 1 or 7, that'll give you a 0 in the denominator, so that cannot be true. Okay, next problem. So in the first one, I'm going to change up to the order and put negative 3x squared plus 3x. And the other one I'm going to do quad form factoring, 1x, 1x. So 1 times 20 gives me negative 20. So factors of negative 20 that'll work for me are, let's see, minus 4 and positive 5 will give me negative 20, and it'll add to the 1x in the middle. All right. And on the bottom, we'll do another quad form factoring times the 3x, which is right there. So 1x, 1x. So 1 times negative 5 gives me negative 5. So only going to work as a negative 1 and a positive 5. We'll multiply to negative 5 and add to negative 4. Okay, so do quad form factoring there. So we can get rid of the x plus 5. But now I still have a term I can do factoring out. With the 3x squared and the 3x, I have a common factor of negative 3. So if I factor out a negative 3, I'm left with, negative 3x. They have an x in common also, I'm sorry. So if I factor out a negative 3x, I'm left with x minus 1. And then there's the x minus 4 is still there. And on the bottom, I'm left with my x minus 1 and 3x. Okay. All right, so we multiply back the negative 3x times the x minus 1, you'll get the original term, which is factoring out. So the x minus 1's cancel, and the 3x's cancel. So we're left with negative 1 times x minus 4 is my final expression, where x cannot equal. Well, if you look at the original, there are 3 terms. So the original term, x can't be 1. The second term, x can't be negative 5. And the last term, 3x, x can't be 0, because any one of those would give us a 0 in the denominator. Okay, pause the video. Try the student problems for yourself. Okay, student problems. We'll do x plus 3 is already a factor. That's done. So then we have to do quad form factoring. So 1x, 1x. So 1 times negative 6 gives me negative 6. So factors of negative 6 that give us negative 1 are positive 2 and negative 3. Okay, because that multiplies negative 6 and adds a negative 1. So on the bottom, I have x squared plus 0, x minus 4. And then I can do quad form factoring with the second one. So I have 1x, 1x. So 1 times 9 is 9. So the factors of 9 will be 3 and 3, both positive because they multiply to 9 and add to 6. Okay, so we have an x plus 3 that cancels. So I'm left with x plus 2 and an x minus 3 over, we'll do a quad form factoring, 1x, 1x. So 1 times negative 4 gives me negative 4. So I need to get 0 as my middle term. So it has to be positive 2 and negative 2. So multiply to negative 4 and add to 0. And then tag on my x plus 3. Okay. So the x plus 2's cancel. So I'm left with x minus 3 over x minus 2. X plus 3 is my final expression. Nothing else cancels. Where x cannot equal plus or minus 2 or plus or minus 3. Because you look at the original one, there are 4 things, 1, 2, 3, 4, that it can't be, or it would be 0 in the denominator. You can write positive 2 and negative 2 separately if you want, but what you'll notice is the books will write plus or minus to account for both terms. This is a shorthand for less writing. Okay, next one, we're going to need factoring out strategy. So I'm going to flip the orders to make sure the higher term is first in the 5x terms. All right, and then the second one is quad form factoring. So 1x, 1x. So 1 times 6 is going to give us 6. So the factors of that it'll work are, let's see, negative 2 and negative 3, because they'll multiply to a positive 6 and add to a negative 5. All right, we'll do quad form factoring again. So we have 1x, 1x. So 1 times 3 gives me 3. So I need to multiply them by negative, negative, get a positive, and add to get a -4, so that works. And then multiply it by a 5x on the end. Okay, so the x minus 3's cancel. So the last term with the 5x's, they have a -5x in common that I can factor out. So that leaves me with x minus 1. Okay, so after I do the factoring out from this term, right, the -5x, x minus 1 cancels, the 5x cancels, so I'm left with -1 times x minus 2, okay, where x cannot equal, so let's take a look here. So let's see, in the first term, x can't be 1. In the second one, x can't be 3. In the last one, x can't be 0. Okay, and that is the end of part 2.